All right, so we are going to do vector homework numbers 1 through 10. So I have the worksheet right here, and I'm just going to write on my own sheet. So number 1, you're going to just find dy dx. So you're taking the derivative of the x and the derivative of the y. So if x is equal to t squared minus 1, and y is equal to e to the t to the third, you know, sorry, getting myself organized here, you know that dx dt is equal to 2t, dy dt is equal to e to the u times the derivative of u. All right, so dy dt, or dy dx, sorry, is your dy dt 3t squared e to the t cubed all over 2t. Now, can you reduce that? You can. You could take one of those t's out. You could get rid of that t and that t, and you have your final answer. So 3te to the t cubed over 2. All right, let's look at number 2. If the particle moves in the xy plane so that any time when t is greater than 0, its position vector is this. Find its velocity vector at time equals 2. So if this is the position, we need to take the derivative to find the velocity. So our position is ln of t squared plus 5t and 3t squared. So if we want to find the velocity, we need to take the derivative. The derivative of ln of u is 1 over u. So it's 1 over t squared plus 5t times the derivative of u. So that's 2t plus 5. The derivative of this is 6t. And we want to evaluate this when t is equal to 2. So if you're plugging 2 into this fraction, you end up with 9 over 14. And you plug it in here and you end up with 12. So your answer is 9 over 14 and 12. All right, let's take a look at number 3. Number 3 says, a particle moves in the xy plane so that anytime t, its coordinates are given by x and y. Find its acceleration vector at t equals 1. So it's coordinates. So that means that they gave you position. And so you're going to need to try and find acceleration. And once you find acceleration, you need to plug in a 1. So your position is going to be t to the 5th minus 1 and 3t to the 4th minus 2t cubed. So in order to get velocity, you're going to take the derivative. So that's 5t to the 4th and 12t cubed minus 6t squared. Now that's not what they asked for though. They asked for the acceleration. So that's going to be 20t cubed and 36t squared minus 12t. And they wanted you to evaluate this one at t is equal to 1. So when you plug in a 1 into this, you get a 20 and you get a 24. Okay? All right, moving on to number 4. Number 4 says, if a particle moves in the xy plane so that at time t its position is blah, find the velocity vector at time pi over 2. All right, so they gave us position. So position is going to be the sine of 3t minus pi over 2 and then 3t squared. And they wanted you to figure out the velocity. So derivative of sine of u is going to be cosine of u. So that's cosine of u times the derivative of that u. So the derivative of 3t is just 3. Derivative of pi over 2 is nothing, so that's gone. The derivative of this is 6t. And we want to evaluate this at pi over 2. So really it's this that we've got to pay attention to. So if we have 3, cosine of 3 times pi over 2 minus pi over 2. So 3 pi over 2 minus a pi over 2 is 3 cosine of 2 pi over 2, which is just pi. So cosine of pi is -1. That means that your first term here is -3. Now, if you plug this in to 6 times pi over 2, you end up with 3 pi. Or am I putting that in there? I'll put it right here, 3 pi. So you end up with your answer is -3 and 3 pi. Okay? All right, number 5. Number 5, a particle moves on the curve ln is or y is equal to ln x, so that its x component has the derivative of this. So you have the actual y, you have the x derivative for any time that t is greater than or equal to 0. At time equals 0, the particle is the point 1, 0. Find the position of the particle at time t equals 1. Okay, so number 5. To get your position, you have the y value. You don't have the x value. You have the velocity for the x. So the y position is going to be ln x. You need to find the x position. So if they gave you x prime of t is equal to t plus 1, and then they said when time equals 0, your point is 1, 0. So that means that you have x of 0 is equal to 1. So if you're given the derivative, how do you get back to the position? You integrate. So you want to integrate t plus 1 dt. So you get t squared over 2 plus t plus c. Don't forget that plus c. Now, they told you when t is equal to 0, x is equal to 1. This is x of t. So you're going to do 1 equals, and then make all these zeros. And you find out that 1 is equal to c. Okay? So your position is t squared over 2 plus t plus 1. Okay? T squared over 2 plus t plus 1. Now, they wanted you, once you found your position, to evaluate that at time t equals 1, I believe. Let's see. Yep. So evaluate at t equals 1. So let's plug in a t equals 1. You have 1/2 plus 1 plus 1. You end up with 5/2. Now look at this one. This is ln x, not ln t. So ln x means you need to plug the x value in. Well, you just have the x value. You just found it. It was 5 over 2. So when t equals 1, your y position is going to be ln of 5 over 2. All right, let's look at number 6. Number 6 says, a particle moves in the xy plane in such a way that its velocity vector is given right here. If the position at t equals 0 is 5, 0, find the position of the particle at t equals 2. So we have to use all of this stuff first before we do anything with this 2. So we need to integrate both of these. Use this to find our c, and then you can plug in your time. So let's see. They told you that your velocity vector was 1 plus t and t cubed. Okay? They also told you that when t equals equal to 0, then you have the velocity vector of 5, 0. So that means when x equals 0, it's going to equal 5, and when y of 0 is going to equal 0. Okay? Because x of t is 5 when time equals 0, and y of t equals 0 when t equals 0. So let's integrate first the 1 plus t. So that's going to be t plus t squared over 2 plus c. So that's x of t. Now, I already said that x of t was equal to 5 when t equals 0. Okay? So if I'm looking for my position function, I've got t plus t squared over 2 plus 5 for my position. Okay? All right, let's integrate the other one. T cubed. Y of t is going to equal t to the 4th over 4 plus c. Well, they said that y of 0 is equal to 0 when t equals 0. So that means that c is just equal to 0 at this point, so my position function there is t to the 4th over 4. Now that I have my position function, the question says find the position of the particle at time equals 2. So now I'm plugging in a 2 into these two positions here. When I plug a 2 into this position, I get a 9. And when I plug a 2 into this position, I end up with a 4. So my position vector at time equals 2 is 9, 4. All right, let's take a look at number 7. Number 7 says, a particle moves along the curve xy equals 10. If x equals 2 and dy dt equals 3, what is the value of dx dt? All right, so we have that xy is equal to 10. Okay? They also then say, if x equals 2, dy dx is equal to 3, and what is dx dt? All right, so we've got to take this right here. We've got to take our particle moving at this little factor. And we can derive this, but when you're doing the derivative of this, you're doing it in terms of t. So not only do you have to do the product rule, but you also have to do implicit differentiation. So you have your first times your derivative of the second, plus your second, times the derivative of the first, and then the derivative of 10 is just 0. Okay? Now, look at all these pieces that they gave you. They gave you the x. They gave you the dy dx. Could we figure out what y is, knowing our x and our dy dx and things like that? Well, let's take a look here. So we got 2 is in our x. Our dy dx is 3, plus y, and then we've got our dx dt equals our 0. So we need to find out our y. Well, if x is equal to 2 and x times y is equal to 10, what does that make y? 2 times what is equal to 10? Yep, it's 5. So you end up with 2 times 3 plus 5 dx dt equals 0. And now you just need to solve for dx dt. So 5 dx dt equals negative 6. I multiplied those together and then subtracted it over. And then dx dt is equal to negative 6 over 5. Okay. So that's the end of number 7. Let's go ahead and look at number 8. Number 8. The position of a particle moving in an xy plane is given by the parametric equations x blah 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 and y blah blah blah. For what value of t is the particle at rest? Well, when is the particle at rest? The particle is going to be at rest when your velocity is 0, 0. So you need your particle to be at rest when your velocity is equal to 0, 0. All right, well, let's look at what they gave us. They gave us the position. Let's go ahead and make this into vectors here. They gave our first position t cubed minus 3 halves t squared minus 18t plus 5. And our y was t cubed minus 6t squared plus 9t plus 4. Now, that's our position. So let's go ahead and find our velocity. So this is 3t squared minus 3t minus 18. And then this one is 3t squared minus 12t plus 9. So we want to find the time in which this thing is at rest. So we need both of these things to equal 0. So we need 3t squared minus 3t minus 18 to equal 0, but we also need the y to equal 0. So we need to find out where both of these are going to be equal to 0. They should have some sort of a time in common, because if one of them is equal to 0 but the other one's not, your particle's not really at rest. Like your x can equal 0, but your y can equal 5, and vice versa. So you need to find a time when both of them are equal to 0. And we do that by factoring. So you're going to pull out a 3. 2. So you factor this to be t minus 3 and t plus 2. So you get t is equal to 3 and negative 2. Now let's factor this one. Let's pull out a 3. So you're going to get t minus 3 and t minus 1. So t should equal 3 and a positive 1. Now again, you want to know, is there a time where both of them are 0 at the same time? So that's going to be the 3. Because sure, your x is at 0 when time is equal to negative 2, but your y isn't. Your y is equal to 0 when t is equal to 1, but your x isn't. The only thing they have in common is 3, so that's when you are at rest. At rest at t equals 3. Alrighty, let's look at number 9. Number 9. A curve C is defined by the parametric equations x and y. Write the equation of the line tangent to the graph of C at the point 8, negative 4. All right, so let's take a look at what we've got here. Number 9. All right, so we need the equation of the tan line. So we need a point, and we need a slope, okay? Now, the point they gave us was 8, negative 4. So we actually have our kind of our equation. We just need our slope. Y minus a negative 4 equals some kind of slope times x minus the 8. So we just need to find that slope. Well, the slope we know comes from the derivative. Well, they gave us our position, t cubed and t squared minus 5t plus 2. And we are going to find our slope when doing our derivative, right? So derivative, we'll just call it velocity. 3t squared and 2t minus 5. Now we also want to know when our derivative is equal to 0, right? No, just kidding. We want to know when it's equal to this point right here. We want to know, because let's look at our picture. Let's say we have some sort of a graph, right? And you want to find the slope of the tangent line at this point right here. Let's say this point is 8, negative 4. Okay? Now, your tangent line, okay, it's going to have some equation, but it's also going to go through the point 8, negative 4. So, our dy dx, or our derivative, is going to be 2t minus 5 over 3t squared. Okay, I got that from here, this velocity. Dy dx is 2t minus 5 over 3t squared. The problem is, look at your point. They gave you 8 and negative 4. So how are you going to find the slope of the tangent line when you don't know t? So you need to find t. Okay, well you need to find t when your point is 8, negative 4. Well, is that going to go with position or is that going to go with velocity? That's going to go with position. This is a point. It's on the graph of the position function. So you need to find out when t cubed is equal to 8 and when t squared minus 5t plus 2 is equal to negative 4. All right, well, t cubed is equal to 8 when t is equal to 2. Just cube root both sides. And over here, add your 4. T squared minus 5t plus 6 equals 0. Then you can factor t minus 3 and t plus 2 minus 2, sorry. So you find out that when t is equal to 3, it's equal to negative 4, and when t is equal to 2, it's at negative 4. So the thing that they have in common is when t equals 2. So you're going to be able to find your slope when t equals 2. So you find out that your slope here is negative 1 over 12. Okay, so you had your position. Well, you needed to know when your position was 8, negative 4, so that when you found your dy dx using your velocity, dy dx, you didn't have an x and a y to plug in. You needed to find a t to plug in. Well, the t that you were looking for is the t that corresponded with the point. And you found that point because of the position function. So you ended up with y plus 4 equals a negative 1/12 times x minus 8. This is hard to see, but that is a negative. All right, our last one for today, number 10. Number 10 says, a particle moves in the xy plane so that the position of the particle is given by blah and blah. Find the velocity vector at the time when the particle's horizontal position is x equals 25. All right, so its horizontal position is x equals 25. Okay, interesting. So we have x of t is equal to 5t plus 3 sine t. And then we have that y of t is equal to 8 minus t times 1 minus cosine t. All right, so it's saying find the velocity vector at the time when the position is x equals 25. All right, so this is our position. So let's find our velocity vector. So the derivative of 5t is just 5. The derivative of 3 sine t, that's just going to be 3 cosine t, right? Derivative of sine is cosine. All right, so how are you going to get the derivative of this? Well, you could FOIL it, and then after you FOIL it, you take the derivative, or you could just do the product rule. I went ahead and I did the product rule. So I have the first times the derivative of the second. Well, the derivative of negative cosine is just going to be a positive sine. Plus the second times the derivative of the first, well, that's just a negative 1. So right here, this is my x, and right here, this is my y for my velocity. All right, now they want you to evaluate this when t equals, oh, they didn't tell you when t was equal. They said when the particle's position is at x equals 25. And they talked about the horizontal position. So they're talking about this. When 5t plus 3 sine t is equal to 25. Now, you can't solve that. Okay, you can't solve that because how are you going to solve for a t? Maybe you took a look at the top and you read the directions. Use your calculator on problems 10 and 13C only. All right, now you could certainly use your graphing calculator, and I'll show you what to do with that, but I'm going to go to Desmos. Desmos is so much easier when you're doing something like this. You want to put in 5t, and we're going to call this x, plus 3 sine, that's in the functions there, sine of x, We're going to close our parentheses. And we want to know where that's going to equal 25. Okay? So we're looking for where, oh, hold on. We got to say x equals 25. We need to make a line. Equals 25. Alrighty, and we want to find out where our t is. Boop. Hold on. Do, 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 do. I want this to be y equals. Like, I'm having trouble here. I wanted that to be a horizontal line. There we go. Now, let's zoom in here. Let's get that point. There we go. Now, our function, 5 plus 3 cosine t, is equal to 25 when our time is equal to 5.446. So we want to figure out our time at 5.446. Okay? Now, how do we do this on our graphing calculator? The graphing calculator, you're going to do very similar. In your y, let's go ahead and clear these out. You would put in your 5 plus 3, all right, sorry, it's 5x plus 3 sine x. And then you would put in your 25. I need to change my window because we are going up to 25. Let's go on up to 30. I'm busy this morning. I'll go up to the 2. Let's go ahead and look at our graph. What did I do? Our y min, let's leave that at -10. Let's do our y max. Let's go up to 30. There we go. Now we're cooking. So it's going to take a minute, but it will graph our line, our curvy thingy, and then it's going to graph that line at 25, and then we want to look for the intersection. So second trace, and you want to go for the intersection, which is number 5. Enter, enter, enter. And it will find that intersection of 5.446. Okay? Now, you already had the 5.446 because that's what Desmos said. So all you're doing is you're taking this and plugging it in here in your calculator. I did it already, and I got 7.009 and -2.227. Okay? All right. So now you've gotten through numbers 1 through 10. Hopefully you can kind of try and figure out numbers 11, 12, and 13. I'll go ahead and post those videos another day. I hope you guys have a good day.